Next, let's take a look at problem number 11 from chapter 5. Here we are considering the following two-person zero-sum game, and we are asked to identify the pure strategy and then determine the value of the game. So we are given the following information for player A and player B. Player B has 3 different scenarios, B1, B2, B3, and player A has 2 different scenarios. So in a pure strategy, we know that the maximum of the row minimums is going to be equal to the minimum of the column maximums. So we need to find these 2 things and make sure that the number is equal. It's a good idea to start by creating another column, and that's going to be our row minimums. So if we look at row A1, we have an 8, a 5, and a 7. The minimum value of those 3 is 5. Then looking at our second row, A2, we have 2, 4, and 10. Our minimum value is 2. Now glancing back at the definition, we want the maximum of those row minimums. So our maximum value of 5 and 2 is going to be the 5. Then we need to compare that to the minimum of the column maximums. So if we find our column maximums, let's give ourselves another row here. Column maximums. Our column for B1, we have an 8 and a 2. 8 is obviously the max there. Then 5 is our max in our second column, B2. And in our third column, the maximum is 10. So again, we want the minimum of the column maximums. So the minimum out of 8, 5, and 10 is going to be the 5. So we can see that 5 equals 5. So we do in fact have a pure strategy. Now this pure strategy, or this intersection point, is what's known as the saddle point. The saddle point is the value of the game. So the value of our game is 5.